Hello everyone, this is Dr. C. Srivardhan Kumar, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. Today I am going to explain about Introduction to Power Electronics. So generally the electrical engineering field may be divided into three categories. One is electronics, power and control. So electronics is essentially deals with the study of semiconductor devices and the circuits for the processing of information at low power levels, nothing but 5 volts, 9 volts, 12 volts. Electronics engineering deals with distortionless production, transmission and reception of data signals of very low power for the order of a few milliwatts without much consideration of efficiency. The electronics is mainly focus on distortionless production and transmission. So there is no need of efficiency. So but coming to the power area deals with the both rotating and static equipment for the generation, transmission, distribution and utilization of the power at high efficiency and high ratings. And the control area is deals the stability and response characteristics of closed loop system using the feedback either continuous or sample databases. Coming to the power electronics is a subject that concerns an application of electronic principle in power engineering to improve the efficiency of the system. This is the main advantage of this power electronics. So it is mainly focusing on the efficiency of the system. So power electronics is the study of conversion and control of electric power. And also, in other words, it is the interface between the electronics and power. So the primary work of power electronic is to process and control the flow of electric energy by providing the voltages and currents in a form of which is optimally suited for consumer demands. So this conversion of electric power is also called power electronic conversion. The conversion of electric power is also called power electronic conversions. Coming to the block diagram of this is the block diagram of the power electronic converter. So here coming to the source may be either a DC generator or PV cells, nothing but a DC supply, and also we can use a AC supply, induction generator and alternators also. The controlled power flows from AC or DC power source to load through this power electronic converter. So the output of power electronic converter may be a variable DC or a variable AC with a variable voltage and frequency. So usually the output power converter, the output of a power converter is depends on the requirement on the load. If we are using a mobile charger, we need a DC output. If we are using we need to run a fan, then we are going to use a AC. Like that, depending upon the load, depending upon the requirement, we can use that particular load. So coming to this power converter, the power converter is classified into 4 different categories based on the input and output. One is AC to DC converter. So we call this generally rectifiers. We can use for a battery chargers and DC drives and excitation system of synchronous machines. And second type of converter is a DC to DC converter. We call it as a choppers, and we can use at DC drives and subway cars and battery driven vehicles. And third one is the AC to AC converter. So here we have the 2 different types of AC to AC converters. One is AC voltage regulator. Here the frequency is constant. So generally in our domestic application purpose, we are using the fans and pumps, that is called AC voltage regulators. And coming to the cyclo converter, there is a here frequency is not constant. We can use for a slow speed large AC drive systems. We are using this cyclo converters. And coming to the DC to AC converter, and we call it as an inverter. So induction heating purpose and UPS and HVDC and renewable energy systems like a wind and solar system, we are using this DC to AC converters. So this is about this power electronic converters. So coming to the feedback signal, this is the feedback signal. This is very important role. Here the feedback signal is measure the parameter of load, that is nothing but voltage, current, speed and frequencies. So these signals are used to input signals of controller. So the command signals are generated. The command signals are generated to this controller. Then the feedback signals are compared with the reference or command signals. Accordingly, the control signals are generated by the controller to turn on the semiconductor switches or devices of power converter. Consequently, the required output voltage at the load is obtained. So coming to this control unit, the controller is nothing but it is the heart of entire power electronic system. So it is generating or providing the trigger pulses to this power semiconductor switches of converter. So the synchronizing circuit is required for the DC to AC converter and AC to AC converter circuits, but that synchronizing circuit is not required for the DC to DC converter. Synchronizing circuit is not required for the DC to DC converter. So here the electronic focus on information of processing and transmission, while power electronic is focusing on the control and conversion, and also it is mainly focused on the efficiency of the system. So the power electronic is also most active in the multidiscipline in electric power engineering like a power systems, electric machines and signal processing, circuit theory, analog and digital electronics, semiconductor physics, analog and digital control system, electromagnetics and also mathematics is also very important for this power electronic course. These all different category, these all multidisciplinary subjects are involving in this power electronic course. So coming to the history of the power electronics, so it is beginning from 19th century with the development of a mercury arc rectifiers. So this is the mercury arc rectifier. So thyroton is a gas filled tube which is used in high voltage electrical switch and a controlled rectifier, and Lenz developed a AC voltage regulator. Controller using a solid state power devices. In 1947, a point contact transistors are developed, Breton and Warden and Shockley. So these three scientists are developed a point contact transistor in 1947. In 1925, a first solid state power devices selenium rectifier is developed without glass tube. So this is selenium rectifier without glass tube. It is developed in the year of 1925. And in 1930, cycloconverters are introduced. Professor Risick, and the bipolar junction transistor using a germanium was developed in the year of 1948. And the first 100 amps germanium power diode is developed in the year of 1953. A new revolution is begun in 1956 with the development of a thyristor. It is a 4-layer silicon PNPN device. It is the most popular semiconductor device of the thyristors family. So SCR which was introduced by General Electric Company in 1957. So these are the basic following properties of the power semiconductor devices. So breakdown voltage must be very high, and on state voltage drop should be low, and on state resistance should be low, and turn on and turn off process should be very fast, and power dissipation capacity is high. So these are the basic 5 properties for any power semiconductor devices. So the power semiconductor devices are available a few volts to several kilowatts and current from a few amperes to several kiloamps. And these are the basic symbolic representations of the power semiconductor devices. Mainly here I am discussing the 5 devices. One is power diodes, power BJT, power MOSFET, power IGBT and thyristors. Here SCR, diode, triac. So this is the representation of diode. Here and this is the representation of the power BJT, and this is the representation of the power MOSFET, and this is the representation of power IGBT and thyristors, SCR and diac and triac. So about all these devices and construction, switching characteristics and everything we are going to discuss in the next modules. And coming to the voltage and current rating, switching frequencies and switching time of power semiconductor devices are mentioned here. So generalized power diode, the voltage and current ratings are 5 kilovolts and current rating is 5 kiloamps. The maximum operating frequency is 1 kilohertz. And the switching on time is 50 to 100 microseconds and switching off time also 50 to 100 microseconds. On state resistance is 0.3 to 0.6 milliohms. And coming to the high speed power diode, the voltage and current ratings are 3 kilovolts and 1 kiloamp, and maximum operating frequency is 20 kilohertz, and switching on time is 5 to 10 microseconds and off time also 5 to 10 microseconds. On state resistance is 1.2 to 1.96 milliohms. So coming to the power BJT, so it is voltage rating is 1400 volts and 400 amps, and 10 kilohertz is the maximum operating frequency. Switching on time is 2 microseconds, off time is 9 to 30 microseconds. On state resistance is 4 to 10 milliohms. Coming to this power MOSFET, 1 kilovolts and current rating is 50 amps. Maximum operating frequency is 100 kilohertz and switching on time is 0.1 microseconds. Switching off time is 1 to 2 microseconds and 1 to 2 milliohms is the on state resistance. Coming to the thyristors, 10 kilovolts and 5 kiloamps is the voltage and current ratings. So here maximum switching frequency is 1 kilohertz and switching on time is 2 to 5 microseconds. Switching off time is 20 to 100 microseconds. Here on state resistance is 0.2 to 0.75 milliohms. Coming to the IGBT, 3.3 kilovolts and 2500 amps is the current rating and 50 kilohertz is the switching frequency and 0.2 microseconds is the switching on time, 2 to 5 microseconds is the switching off time, and 2 to 40 milliohms is the on state resistance, 2 to 40 milliohms. So coming to the GTO, 5 kilovolts and current rating is 3 kiloamps and switching frequency is 2 kilohertz and 3 to 5 microseconds is the switching on time and 10 to 25 microseconds is the switching off time, and here 2.5 milliohms is the on state resistance. Coming to the triac, here 1200 volts and 300 amps is the voltage and current ratings. So maximum operating frequency is 0.5 kilohertz and 2 to 5 microseconds is the switching on time and 200 to 400 microseconds is the switching off time. Coming to the on state resistance is 3.5 milliohms. And coming to the MCTs, here 1200 volts is the voltage rating and 100 amps is the current rating and 20 kilohertz is the switch maximum operating frequency and 0.2 is the switching on time and 50 to 110 microseconds is the switching off time and 10 to 25 milliohms is the on state resistance. So these are very important when we are solving the problems. Coming to the, based on the following factors, the power semiconductor devices are classified in different ways. So here these are the, based on the following factor, the power semiconductors are divided into different categories. So here number of layers, and coming second one is based on the driver circuit and carrier signals and number of terminals in the device and triggering methods. So based on these 5 different factors, the power semiconductors are classified. So first coming to the layers, power semiconductor based on the layers, these are classified into 4 different categories. One is the 2-layer devices, 3-layer devices and 4-layer devices and multi-layer devices. So coming to the 2-layer devices, example is power diodes, and 3-layer devices, example is BJT and MOSFET. 4-layer devices is thyristors. So coming to the, depends upon the driver circuit, the power semiconductor devices are different categories. One is current controlled and second one is the voltage control devices. Coming to the current control devices, thyristors and GTOs. Coming to the voltage control devices, MOSFET, IGBT, SIT and MCTs. So coming to the next category, based on the carrier signals, majority carrier signals and minority carrier devices. Majority carrier devices are unipolar devices, nothing but example is MOSFET and SITs, and minority carrier devices are bipolar devices, we call it as a minority carrier devices or we call as a bipolar devices. So power diode, thyristors and GTO, IGBT and MCTs. And classification of power semiconductors based on the number of terminals. Here these are the two different categories. One is the 2-terminal devices and second one is the 3-terminal devices. For 2-terminal devices, PN junction diodes, Schottky and fast recovery diodes, and 3-terminal devices, example is BJT, MOSFET, IGBT, thyristors and SIT and MCTs. So these are the two different categories based on the number of terminals. So coming to the triggering methods, based on the triggering methods, pulse triggering methods, example is thyristor and GTO, left level triggered methods devices, MOSFET, IGBT and SIT and MCTs. So these are the two different categories in the triggering methods. So these are the different factors. So first one is based on the layers, based on the driver circuits and carrier signals, and depending upon the terminals and depending upon the triggering methods. And coming to the applications. So these also power electronic devices also used in the residentials and home appliances and industrial applications and commercial applications also we can use these power electronic devices. Transportation, nothing but EV vehicles and railway systems, all we are using this power electronic converters. And power system applications in HVDC system and telecommunication applications and aerospace. So these are the different applications for power electronic devices. So advantages. The main motto of these power electronic devices is improving the efficiency due to less losses. Why the less losses is nothing but power electronics are not having any rotating parts. Power electronic devices are not having any rotating parts. So losses are very less. So that's why we are going to improving the efficiency of the power converters. High reliability of power converter based systems, and life period of power converter circuit is also very long, and less maintenance is required due to the options of moving components in the power electronic converters. So there is no rotating parts, so there is no any mechanical losses, and also there is no any moving components. So that's why the maintenance is also required, less maintenance is also required. And the dynamic response of power electronic converter is very fast compared to the electromechanical converters. The size and weight of power electronic converter is less, hence the installation cost is also very low. These are the main advantages of power electronic converters. So coming to the disadvantages of the power electronic converters, and generate the harmonics in supply system as well as the load. So generation of harmonics is the disadvantage of these power electronic converters. So for improving the efficiency, so it is advantage. So generation of harmonics is also one disadvantages. According to IEEE standards, the THD value, total harmonic distortions value, must be less than 5. So then only the circuit is good. So by using these power electronic converters, so generation of generate the harmonics in the system supply, generation of harmonics in the supply system as well as in the load. So as per the standards, the THD value must be less than 5. And coming to the AC to DC or DC to AC converter, the operate at low power factor under certain conditions. And always try to avoid the low power factor operation of power converters. So this is one disadvantages. And the overload capacity of power converters, power electronic converters is low, and the power electronic cost is also very high. These are the 5 disadvantages of this power electronic converters. So here today power electronic have revolutionized concept of power control and conversion, and the power electronic based systems has discussed elaborately, and history of power development of power electronic devices also explained clearly in this chapter. And next we are going to discuss about the construction of power diode and power BJT, power MOSFET and power IGBTs, and after that power IGBT and SCR, silicon control rectifier characteristics, everything we are going to discuss in the next modules.